Thank you very much. So this is quantitative methods. Okay. Quantitative methods, as all of you are aware of. What I plan to do today, I'll walk you through the course outline and then maybe set some general expectations for the course. And then we would do a few things by way of foundational concepts, okay, to be able to build our understanding before we jump into computations a bit later on in the course.
Good
Now,
morning.
with regards to the course outline, I think I'll make that available on the virtual class platform, right? What you call the LMS. And so maybe that's something that we can look forward to. But in general, as you may have been exposed to, right? The quantitative methods course encompasses some uh, general numerical skills that are important for secretariatship, managerial people, administrative people, to have as part of their training, right? So typically people would ask, I mean, I'm reading secretariatship and maybe administrative practice, right? But what has this got to do with quantitative methods? It's simply because we're living in a big data world. All right. And because data is all around us and it's almost impossible to do anything significant these days without doing some data analysis. So it's very important that regardless of your background, regardless of your preferences or anything, you still need to be equipped with some vital skill sets when it comes to analyzing and then understanding data, right? It's not enough to just say that I am an admin person, so this data related issues have nothing to do with me. No, it has everything to do with you. All right. Now, the second thing is maybe by way of setting expectations for the course. A lot of people come into the course with a closed mindset. What I mean by a closed mindset is once you begin to say things like, as for me, I don't like calculations. As for me, anything calculation is not for me. That's an outright failure. Okay. That's like failing in advance. All right. Everything can be taught and everything can be learned if only you're open to. All right. So I want to disabuse your minds of some of these presumptions that you make of yourselves, right? I do understand, yes, for most of you, the last time you did anything relating to calculation, maybe sometime in senior high school, where you were forced to do some core math, right? After core math, you've not touched anything related to calculations. And so I do understand that there will be some challenge. So in that regard, you need to recognize that challenge. Okay, embrace that challenge, and then now that you know the reality, put in a lot of work, right? Another thing I would say is you cannot study or read this course like one of your other vanilla courses, all right? This is not a reading course where you can lie on your bed and cross your legs and then read and then hope that you'll get it, all right? You can only sail through this course with practice and actually working things out. All right, actually writing and solving problems. That's the only way that you can get ahead. All right, it's not just about reading solutions. No. Okay. So these are just a few things that I would leave you with before I begin. So typically when I come to class, whether in person or virtual, I would normally like to, especially in person sessions, I normally like to do manual teaching. So I hardly use PowerPoint presentations for, especially when I am inside, the lecture hall. The only time I may use a PowerPoint presentation is when we're doing virtual sessions, okay, like online sessions. And even with that, I would complement it with writing, okay, writing, doing digital writing. And this is because if I just focus on PowerPoint slides, right, everything is solved, and then I'm just walking you through. It's very easy to look at the slides and say that, oh yes, so you do it this way, oh X becomes this, oh you transpose the matrix, you go here. It's very easy to just tell a narrative. But at the end of the day, when I give you a problem that, okay, now do this on your own, you'd realize that you really have not understood it. Okay. So there's something about writing. There's something about writing that helps a person to learn and to understand. Okay. So that's something I would want to encourage all of you to do, especially as we are doing these Zoom sessions. Well, I'll come to these Zoom sessions, but even in the class, okay, whatever I'm writing, follow through and write as well. Okay, most of you like to just take pictures, like paparazzis, and then you tell yourself that you'll find time and then transcribe it into your notes. But you and I know that you'll never make that time to transcribe. And by the end of the semester, the only notes that you have are screenshots and and you're tackling yourself that you're learning, right? I don't think that's the way to go. So when we come to class, there'll be a lot of writing that you can expect. Okay. So I'm just setting the expectation right now. Also, in cases where we're having Zoom classes, like I said, with Zoom, we may decide to convert some of the Zoom sessions to in-person sessions, okay, when the course progresses and things become a bit more intense. All right. However, in instances where we're still having Zoom, I want you to take it with the seriousness of an in-person session. Okay, most students see virtual sessions as less important. Oh, I mean, if it's an online week, it's a free week for us. The lecture is not going to be so serious. And after all, even if, we can just tell the lecturer that we were losing connection within here. So if he can repeat, please keep in mind, whatever I teach virtually or online, I will not repeat in class the next time. I take Zoom sessions and virtual sessions as if they are in-person sessions. It is a class. It is also a lecture, and it has to be treated with the same level of importance. All right. So I don't want you to think of virtual sessions as less important. Okay. They are equally important. Okay. So if anything else comes to mind, I'll do all to let you know. But I think these are the ground issues for now. So, for example, with today, with regards to what I wanted to do, I have some slides that, of course, I'll share later on. But at the beginning, I will be doing a bit more writing, okay, because I want to actually walk you through, we kind of building ourselves from ground up, okay. So, by way of the course outline, I'll retrieve that later on, and then I think I'll just make that available. But in general, we'll start by looking at, in general, what quantitative methods is, its importance, and we'll talk a bit about statistics. We'll talk about the framework of statistics. We'll talk about population and sampling. We'll talk about measures of central tendency. We'll talk about measures of dispersion. We'll talk about coefficients of variabilities. We'll talk about quartiles. We'll talk about correlation analysis. We'll talk about regression analysis. Okay, these are all very, very crucial topics that if you take seriously, I think you would do well. All right. So I also want you to come into the course with a certain mindset, a mindset of possibility, right? A mindset that says that yes, maybe math or statistics is not really my stronghold, but I'm willing to put in the effort. Okay. And just to give you a sense of how the difficulty level of this course, this is like if you take all the mathematical sciences, all right, and let's say you take 1%. Okay, 1% is what? 1/100, right? Okay. Now the level of difficulty of this course is like this 1%, okay? take another 1% of this. So it's like 1% of 1%. Okay, that's a very small number. 1% of 1% is, I think, is what, 0.001, right? Okay, so this is like 0.0001. So this simply means that if you divide the mathematical sciences into, or the statistical sciences into 10,000 parts, okay, quantitative methods is like just one part, okay? 0.001 is just 1 over what? 10,000. So quantitative methods is like 1,000th part of the statistical science, 1/10,000th part of the statistical science. So it's just watered down statistics, right? It's nothing extraordinary, nothing to be scared of, right? It's just very basic. So if you decide that, okay, it's something you're willing to put in the effort, I don't see why you shouldn't do well. Okay, so I'm about to start the lecture now. As we move on, if there are any questions, just show by hand, okay, using the emoticons, and then, or if it's a passive concern that you have, or a question that you think you can type into the chat area, you can also do so. But if it's something that you want to voice out, just show by hand, and then you can talk. All right, good. So with that being said, I think let's just jump right into it and do something. Let's start by, we're looking at quantitative methods. Here we're looking at what? The approaches. Okay, we're looking at number one. We're looking at principles, theories, and modalities. Okay. For studying and comprehending quantities. Okay. In quant methods, we're going to study the principles, the theories, and the modalities for studying and for comprehending quantities. All right, for comprehending quantities. Now, the quantities here that we're talking about, when we say quantities, what are quantities? Quantities are measures of values. Okay, measures of values. Measures of value. So as we move on in the course, you'd realize that the measures of values that we're actually talking about are simply data. Okay, so essentially in quantitative methods, we're going to be studying the principles, the theories, and the modalities for studying and for understanding data. Okay, that's really, the end goal at the end of the day. Now, in studying quantitative methods, we need to employ some tools. Okay, we need to employ some tools. And one of those tools, okay, is statistics. Okay, so now let's look at what statistics. All of you may have heard about statistics in one way or the other. Okay, now statistics is a very broad area. It's a broad subfield of mathematics. All right, and it constitutes different aspects. So first of all, statistics, what is it? It's a mathematical science. Okay, It's a mathematical science which is composed of 5 different phases. Number 1, collection. Number 2, organization. Number 3, analysis. Number 4, interpretation. And then number 5 is presentation. Of data. All right. For informed decision making. Okay. So statistics, first of all, is a mathematical science, meaning that statistics uses mathematical elements. All right. And it's a science as well. So it's a mathematical science which involves the collection, organization, the analysis, the interpretation, and the presentation of data for informed decision making, right? So the goal of statistics is essentially to help stakeholders in academia and then in industry to be able to make informed decisions. When we say informed decisions, we mean evidence-based decisions. Okay, you're making decisions based on credible based on a credible basis. Okay, you are not making a decision simply because I feel like we should do this. I think we should. For example, if you take a government that wants to implement some developmental initiatives, right? The government cannot just do like a cookie cutter approach, all right, where randomly the government will just say, okay, I think our people need this. I feel like they need this. Right? When you do that, you will misappropriate resources, okay, and you will end up not allocating already scarce resources to to where they rightfully belong. Okay, because resources are scarce, every decision that we're making as a government, as a university, as as a city, as a municipality, as a family, as a household, or as individuals, has to be informed. Okay, yeah. So it's just like an individual, right? You know your means of income. I mean, you know your income and you can't afford not to, whether you're buying something or you're investing in something, you need to think critically and then gather some data points, right? You need to have a basis for the action that you're taking. So that's essentially it, right? So normally we call this the statistical pipeline. The statistical pipeline. Okay, these are 5 things. So as we move on in the course, when I say statistical pipeline, I want you to think about these 5 different phases. All right, the collection of data, the organization of data, the analysis of data, the interpretation of data, and then the presentation of data. Okay, and again, why are we doing all this? To help stakeholders like yourselves and I make informed decisions. And like I said, informed decision means evidence-based decisions. decisions that are data-driven, okay? Data-driven decisions. So let's take them one by one. I mean, as we move on in the course, we'll actually spend a lot more time talking through each one of them. But for now, let me just give a quick overview of each one of them. When we take collection of data, all right, you're collecting data. Collection of data simply means or simply involves the process of obtaining data from its origins or sources. All right. The process of obtaining data from its origins or sources. Now, we know what data is. Although as we move along, I'll give you a more technical perspective of what data is. But I'm sure at this point, if I'm to ask the class, what is data? All of you will tell me one thing. Data is raw information. But then the question is, what if I ask you what is information? Then you tell me information is processed data. Then again, what is data? Data is raw information. Then again, what is information? Information is processed data. So in other words, you're using information, which is also another big word. You're using information to explain data, and you're also using data to explain information. And it's like this unending pendulum, that just keeps swinging back and forth. But since this is the very beginning, it is fine for now to think of data as raw information, okay? Unprocessed, unrefined information. For now, it is all right to think of data that way, all right? But as we move ahead, you would appreciate data in a more holistic sense, all right? Good. So again, collection of data involves the process of obtaining this data, okay, from its raw sources or origins. All right. And when we talk about, as we move on, we'll understand a bit more as to what we mean by the origins and then the sources. All right. Number two, when you collect that data, normally the data is raw. I mean, that's why it is data, right? It's raw. So anything that's raw is a bit dirty, right? It's not clean. So what do? You need to do some cleaning. You need to do some laundry. You need to do some washing to make it look good. All right. It is in very lay terms. So organization of data involves the classification or categorization or sorting of data into refined forms for further processing. Okay, organization involves the process of categorizing, classifying, or sorting data into refined forms for further processing. So let me give you an example. Let's suppose that a political agency or party comes to campus, right, ATU, and decides to meet with the student body. And the reason for coming to see you is to take your opinions, take your concerns about what you would like the next government to do for tertiary students. All right. Now, ATU is about 20, 25,000, thereabout. Supposing that they're able to engage with all 20, 25,000 people, Kwame will say this, Ama will say this, Fusua will say this, Kwame now will say this. So all the 20,000 people would have their turn and say something. Okay. You see, that is raw information. So they've come to collect data. So that is raw information. It is raw because these are thoughts of individuals and they've not been refined. They are not filtered in any way. Okay. And you are the sources. The university is therefore the source. Okay. Now, the question is for this political party to actually make sense of all the 20,000 views, it's impracticable for them to just take the 20,000 views and run with it and say that they want to implement it. No. What they have to do is to organize the data. Okay. So by organization, they will do some classification or some categorization and then some sorting. Okay. So you'd realize that at the end of the day, 20,000 people have spoken, but you may realize that, oh, I can actually bottle their views into, let's say, just three silos, right? Maybe a part of the student body are more interested in, let's say, infrastructure. They say that the next government, when we come to infrastructure, right? They are saying that the next government, when we come, we should build a lot more, infrastructure. And then, so this could mean maybe even more institutions, more departments, more faculties, more hostels, and so on and so forth. All right. Then, after looking at the data from 20,000 people, you may also realize that though it's 20,000 views, but there's also a section which is basically saying the same thing. Maybe these people, they're more interested in, let's say, educational, let's say financial aids, financial aids. So by financial aids, I mean things like maybe scholarships, bursaries, some advances, educational sponsorship schemes, and so on and so forth. All right, just to help to alleviate the economic plight of students. Then, if you read through the 20,000 maybe comments or views, you may also realize that okay, maybe we have what group A, group B, and then group C. Okay, you may also realize that there's one group which is also interested in, let's say, um, so let's say infrastructure, financial aids. What else are students even interested in? What
Say
is the
data.
group B? Say it again.
Bundle.
What bundle? Did you say bundle?
The
Okay,
Wi-Fi.
I'm not hearing you, but anyway. So so interesting. So, well, let's say bundle all those things can be part of infrastructure, right? Because it means that when the government comes, they need to build more telecommunication masts and things like that. So bundle can come under infrastructure, and then financial aids, and then let's say general, um, maybe let's call this well-being. All right. Let's make it industrial corporations. Okay, students want industry to participate in their curriculums as much as possible. So by that, meaning that because of the unemployment situation, students would like every now and then for industries, right? Companies and so on and so forth to come to campus to give talks and to do symposias and things like that. Okay, so the students can get the chance to build networks ahead of their graduation or completion. Okay, so you realize that the raw data set, once you are doing organization, you're able to bottle them into some groupings. So in that regard, as a government, it's very easy for you to prioritize okay, and focus on them than to look at 20,000 views and opinions individually. Okay, so we're saying that after collecting the data, the 20,000 views, now organization involves the process of classifying, categorizing, or sorting of the collected data into refined forms. But this is not the end point. Okay, so for further processing, okay, for further processing. Good. Now let's look at analysis. Analysis simply is the investigation, or so the in-depth investigation or interrogation of data to uncover insights. Okay, the interrogation or in-depth investigation of data to uncover relevant insights. All right. So now that you have done some refinements, by way of organizing your data, you now want to understand what the data is telling you, right? So you are interrogating the data as if to say the data is a human being standing in front of you. Okay, so you're interrogating the data, or you are investigating the data to see if you can uncover insights. Okay, you see, the whole point of research is to solve a problem. All right, we're trying to solve a problem, or we're trying to understand a certain phenomenon. Okay, we're trying to answer a question of why is something happening? Why is something the case? Why are we facing a particular situation as a country? Why is this happening? And so on and so forth. So you can only answer these questions when you subject the data to scrutiny. Okay, you are scrutinizing the data. And this is where quantitative methods comes in heavily. Okay, because there are methods that we'll be studying to help us investigate, to help us interrogate, to help us scrutinize the data. Okay, so that we can understand, or we can uncover these insights from the data. All right, good. Now that you've collected the data, you've done some organization, you've done some analysis, keep in mind, you are the technical person. But typically when you carry out research and you do the analysis, you come up with some findings, all right? But we need to understand these findings, okay? So interpretation is key. Interpretation is key for both yourself as the researcher and then also for your target audience. If you yourself don't understand what you've analyzed, how can you explain it to someone else? All right? So interpretation is the process of deducing meanings. Okay, is the process of deducing meanings from the findings of the analysis, or is the process of deducing meanings from the outcomes of the analysis. All right, so that's just about it. Then we come to a very vital part, which is presentation. We don't conduct research to sit on it or to put it under our beds and sleep on it. Okay, research is for the consumption, or research is meant for human good. Okay, we conduct research to help us understand a particular problem in our society, in our governance, in our institutions, and so on and so forth. All right, in our companies or organizations of work, etc. So you've collected data, you've done some organization, you've done the analysis, you've done the interpretation. We now need to disseminate the findings so that it could be widely consumed, okay, for societal benefit. So for example, let's say you wake up one of these days and you are the board secretary for, let's say, Tallow Oil, or you are the board secretary for AngloGold Ashanti. All right. Now, they have an annual general meeting coming up, let's say sometime in December. And you've done some research on the company's productive capacities over the past quarters, okay, from the first quarter, second quarter, third quarter, into the final quarter. All right. But you see, you are the technical person. You are using so many technical tools and quantitative methods to do your analysis and everything. But the people that will benefit from your work may not be as technical as you. So you need to find a very intelligent, a very understandable way of explaining what your findings are without being too complicated. So that's where interpretation is key. Now, presentation here, right, has to do with, it's not just about wearing a suit or dressing nicely to go stand in front of people with a PowerPoint slides, beautifully animated, and then you say you're doing a presentation. Yes, that is a presentation, but that is not the only definition for a presentation. Here, when we say presentation, we mean disseminating, okay? The process of disseminating the findings of the research. Okay, disseminating the findings of the research. When you're disseminating something, you are making it widespread. You're making it publicly available. All right. So presentation can be a physical presentation, like a formal or a corporate presentation where you're standing in front of people to deliver a presentation. It could also be in the form of a written report. Okay. It can be in the form of coming to radio stations and television stations to explain a certain finding, and so on and so forth. All right. So that's just about it for the statistical pipeline. So we do all these things to help us make informed decisions. Are there any questions? Are there any questions or general comments?
No, sir. No, sir.
No, okay. Okay, that's fine. So then we would proceed. Okay. So the next thing that we would look at is the various aspects of statistics. Or what you would call the types of statistics. All right. Or the schools of thought in statistics. So we have, all statistics can be categorized into two. Okay, so we have, just a second. Okay, so we have types, okay, or aspects of statistics. So we have number one. We have descriptive statistics. Descriptive statistics, and then we have inferential statistics. All right, descriptive and then inferential statistics. What is descriptive statistics? So with descriptive statistics, right, so with descriptive statistics, it involves the summarization of data. Okay, so involves summarization of data. Okay, using quantities. Or using verifiable quantities, okay, or objective quantities. All right, so you can insert it there. It involves the summarization of data using verifiable quantities or objective quantities, such as means, and medians. Or if you like, I can make it a bit more technical. So we'll look at means and medians and all that, okay? But let me just maybe refine it a little bit. So it involves the summarization of data using quantities such as central tendency, and dispersionary measures. And central tendency and dispersionary measures are actually is a topic, okay, that we would treat together. But I just want to, give you a heads up. So with descriptive statistics, okay, we are basically we're basically interested in summarizing data using quantities. Okay. So for example, if I come to class right now and then I collect all of your ages, all right, let's say there are about 50 people in the class. So when I collect all of your ages and I strike the average, Okay. When I strike the average, I would say X bar. And don't worry about these things, right? I mean, when we start doing the calculations, you'll understand what these things mean. So when I say X bar into brackets, so X bar subscript age, okay? So this into bracket means the average age, or let me say the mean age. So when I say, so when I collect the data and then I find the average and I come up with a number, I say X bar is, let's say, 25. This is a descriptive statistic, okay, because it is a data summary and I'm using a central tendency measure. Okay, this X bar is a mean. Mean is a central tendency. All right. So this is descriptive statistic. All right. So basically, descriptive statistic is very objective. All right, it's very objective. So whether I am the one who comes to class to measure the age of members in the class and then find the average, or somebody else comes, would all arrive at the same 25 years, if only we're doing the computation correctly. Okay, so descriptive statistics basically is telling the situation as it is. All right. So descriptive statistics is the aspect of statistics which involves the summarization of data using quantities. And examples of those quantities are central tendencies and dispersionary measures. Okay. And I've given you an example of a descriptive statistical statement. Okay. When I say X bar is equal to 25, or an example, if I say X bar um, income, we normally use Y for income, right? So X bar income, or let me just write it in full, just so that in case you are taking notes, you'll not be confused later on. So let's say X bar income. Okay, so this is what average, or let's say mean income. Supposing you were a company and I come to class, I take all of you, your salaries or your incomes, and then I find the average or the mean. Okay, and then let's say I come up with a value. Let's say the average is 3,000 Ghana cedis, for example. Okay, this is also a descriptive statistical statement. All right, you are using a quantity. You are using quantities, okay, to summarize some data in a given situation. Okay, so these are two examples of descriptive statistical statements. All right, now let's move on to talk about inferential statistics. Can I move to the next page? I think we've run out of. Can I move on? Now let's look at inferential statistics. Okay, so with inferential statistics, it involves
Yes, sir.
Okay. Now, the next thing I want us to talk about is, you see, so far, everything that we've been saying is revolving around data, 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 data. All right, data. Now, what are the decompositions of data? Right? What are the constituent parts of data? So I want us to look at that next in the way that you know data to be raw or unprocessed information. But as we go on, your understanding would expand, okay, on exactly what constitutes data. So let's first start by looking at characteristics. I mean, what a variable is. All right. So a variable is a characteristic that possesses different numerical values. Different numerical values. So for example, if I say I want to write in this area, just a second. Yeah. So if I say, for example, X, wait, I think it's too big. Okay. So if I say, for example, X is equal to 95,000, for example, X is a variable, all right? X is a variable. So tomorrow, maybe today X is 95,000. Tomorrow X will be 15. Tomorrow X will be 72, and so on and so forth. All right. But instead of even using X, let's say that we're collecting some data, okay? And typically when you collect data, there are different variables in there. All right. So let's say I'm collecting some data on members of, the SMS 209 class. Okay. So let's say I'll collect data on your ages. What other information can I collect on you? Let's say age, weights, heights. Okay. And then let's say temperature.
Complexity.
Okay. Good. So it could be, so let's say if there are, let's assume there are 5 people in the class. So individual 1, 2, 3, 4, 5. Maybe Kwame, Owusu, Memuna, and so on and so forth. Okay, 5 people. So somebody may be 19, 21, 25, 24, and then 20. Okay. Somebody's weight can be 60 at 19 years old. Let's say you are about I don't know. Well, it depends on your feeding. So let's say 50 kilograms. This might be 60. This 25 might be, let's say, 75. Let's say 74. And then let's make this 55. Okay, heights. At 19 years old, depending on your genetic makeup, maybe you're about 5 points, or sometimes 4.9, 5.23, thereabout. Anyway, so you get the drift. I can populate this area. Okay, let's say we have some heights. We have some heights. Okay, for all these people. You realize that for individual 1, individual 2, individual 3, individual 4, individual 5, they all have age, weight, height, and then temperature. But you realize that it changes. Age is not just one thing. Okay, and weight is not just one thing. Height is not just one thing. Temperature is not just one thing. Okay, so we call these things the age, the weight, the height, the temperature. We call them variables. We call them variables. Okay, that's why we are saying that a variable is a characteristic that possesses different numerical values or categories. Okay, so the same age it's changing from 19 to 25. Okay, the same weight, it's changing across different people. The same height is changing. So because it's not static and changes, we call it variable. Variable meaning it varies, okay? It changes. Okay, so different numerical values or categories. In fact, we can even add another variable, gender. Okay, gender. Okay, gender. So maybe the person one is a male, the second person is also a male. We have a female, male, and then finally another female. So you realize that the same gender, but it is not one thing. The moment you have just one thing, then we can't even call it a variable. Then that becomes a constant. Okay. So once there is some alternation in the value, then we call it a variable. I hope it makes sense. So what I want us to look at is, now think about it. Variables contain data. All right. The 19, it is a data. 21 is a data. 25 is data. 24 is data. 20 is data. All right. So this variable is storing a series of data. The weight is storing a series of data. The height is storing a series of data. Temperature is storing a series of data. Gender is storing what? A series of data. Okay. So the variables are like the storage points of data. Therefore, when we are studying the types of variables, at the back of your mind, I also want you to know that the types of variables are the same as the types of data. Okay, so let me do like a stroke here. So variable stroke data. Okay, so when we're studying types of variables, it's the same as types of data. Okay, because variables contain data and data are contained within variables. So their types will be the same. Just that when we're explaining, we'll explain it a bit differently, but the types structurally are the same. So let's just look at them. Now, every data or variable, okay, in the world can be grouped into two parts. We have qualitative data and then quantitative data. Okay, we have qualitative data and then quantitative data. Now, qualitative data can also be broken down into two parts, nominal data and then ordinal data. And then quantitative data can also be broken down into two parts. We have discrete data and then continuous data. Right? Let's understand what these different decompositions mean. Let's start with qualitative data. We're saying that qualitative data is generally described by words or letters. Okay, words or letters. So normally, you see, I want you to think about this word qualitative, qualities. Okay, what are qualities? Qualities are attributes. Okay, so normally qualitative data are data that describe attributes. Okay, and normally attributes are described using words and letters. Okay, so for example, let me collect data on your names. Okay, if I decide that I'm collecting data, let's say, let me create names of members in the class. All right, so the main names of members in the class, there is Kofi, there is there is Amma, there is there is Ombefi, and so on and so forth. Right? These are attributes, these are letters, these are labels, okay, these are words, but they are data. Okay, so whenever you collect data and realize that they can be described or they are describable by words and letters, all right, then you have qualitative data. Okay, so for example, color, ethnic groups. Let's say if I can create another data set containing ethnicities of members of the class. So I can create ethnicity. So ethnicities, right? Let's say somebody is let's say Dagomba. Let's say Ewe, let's say Fanti, let's say Asante or is it Akan? Let's say 4. All right. Again, these are traits. These are things that are describing where a group of people come from or who certain people are. All right. And these are all letters and words. Let's look at quantitative data. Let's look at quantitative data. Now, with quantitative data, as the name depicts, we're talking about what? Quantities. Okay, we're talking about quantities. So when you hear quantities, what comes to mind? We're talking about numerical values. We're talking of numerical values. So quantitative data involves numbers and are the result of counting or measuring. All right. So, for example, we have more specific examples. So again, age. Ages of members in a class. So 24 years old, 25, 21, somebody's 30. And then maybe, so there are 5 members of the class. And then let's say someone is 2, 3. All right, 2, 3. So this is quantitative data. Okay, quantitative data. Or the number of buildings in a city. Okay, it is a number. Okay, so let's say if I have cities, maybe number of buildings in different cities in Ghana. So let's say I'm taking 5 cities. All right, so let's say in city A, there are 500 buildings. In city B, there are 450. In city C, there are 700. In city D, there are 1,000. And then in city E, there are 890. Okay, all these are values. Okay, so whenever you have a numerical component in the data set, or when the data set constitutes numerical values, then you have quantitative data. They are quantities. All right, good. Now let's look at quantitative data. like I said, that we have two breakdowns. Oh, I shouldn't have even erased this example because I would have needed it. But I mean, I'm sure you were taking notes, so I can always refer to it. Now, quantitative data can be discrete or continuous, depending on two things. It depends on countability or measurability. Okay, now you realize that I can give you two data points. They're all numbers, but still they are different in the sense that the question is, if you look at a particular quantitative data, the question is, are you able to count or you are only able to measure it? So I'm giving examples here. The number of students in a given class, for example, your class, right? If you are 50 students or 60 students, 60 is a quantitative data point. But how do we get 60? The 60 can be obtained by counting, or the number of books on the shelf, or the number of tables, or the number of chairs in a lecture hall. All right. These are countable quantitative values. So whenever you have a countable quantitative data point, we call it a discrete data. On the other hand, you may have some quantitative data points which are not countable. Yes, they are quantitative, but they are not countable. For example, I mean, in that case, they are continuous. Okay, so for example, if I say, what is your height? Height, you tell me, well, maybe I am 5'9", or I am 6.1, or you are 4.2, okay, or you are 6.3. But these values, although they are quantitative, but they're not countable, they're only measurable, right? You can only measure height, or let's say your body weight or body mass. You tell me you're 60 kilograms, 40 kilograms, 72 kilograms. These are not countable values. You cannot tell me that I am going to count my height or I'm going to count my weight. You only measure, they are measurable. Or let's take your body temperature. Nobody counts temperature. We measure temperature, okay? The atmospheric temperature, the atmospheric pressure, all these things are measurable, although they are values, all right? So think about it this way. Discreteness or continuity of the data is based on countability or measurability, all right? And you should be able to give examples. So, I mean, these things are readables. I'd wanted to, so I need to explain now the nominal and then ordinal. All right, the nominal and then ordinal. Let me explain it this way. So think about this. You see, nominal, nom. Anything nom has to do with names. Okay, it's like French, les noms. All right. So when we say nominal data is definitely qualitative data, but it's nominal because it's simply a collection of attributes or names. And when I say names, I mean labels. Okay. So for example, if you walk into a restaurant, let's say I walk into uh, your class, your restaurant, SMS 209 Restaurant and Hotel and Services Limited, and then they serve me with a menu. Right? I'm served with a menu. So let's create a data set on menu. Let me actually go back and use the screen. Okay. Now, let's suppose that we go to a restaurant and then you're served with a menu. All right, you're served with a menu. So you have what kind of foods do you serve in your restaurant? So let's say it's a local restaurant. So we have fufu. Let's say TZ. What else?
Say
Bang.
M2.
Petredeci.
The lady who just said Fitredechi, I can tell you're really your tongue says a lot. It looks like your tongue has been having a lot of Fitredechi. The way you actually pronounce it, the way you
Yes,
pronounce it,
sir. She's Amelia.
yeah, you really pronounced it with a traditional tongue.
Yes.
Okay,
I take it.
I see. So what else? Maybe let's just add just to make it 5. This is really not local, but anyway. So if we look at this, okay, for example, if you look at this menu, the menu contains 5 different meals. Now, when we say nominal data is a type of qualitative data which constitutes names or labels without any sense of hierarchy in the data set. So listen very carefully. We're saying that nominal data is qualitative data which constitutes labels or names without recourse to hierarchy or order. All right. So what do I mean? If you look at this data set, you cannot look at this data set and tell me that fufu, because it comes first, all of a sudden fufu is more important than akpele, right? Or
Sir.
let's say, yes, is someone talking?
Sir, please, can you give the definition of nominal data
Can
once
I
again?
do it?
The definition of nominal data.
Of nominal data. Oh yeah. Yeah, I'm just
Yes.
saying that nominal data is qualitative data, which constitutes names or labels without recourse to order or hierarchy. All right. Quantitative data is nominal data is qualitative data, which constitutes names, stroke labels, without recourse to hierarchy or order. All right. So, in other words, if you look at the data, inherently, there is no sense of importance. There's no sense of relative importance, right? They're all the same. Okay. Banku is not all of a sudden more important than beans, or beans is not more important than TZ, or right? They're all foods that people like. So, depending on who you are, you would choose or you would have preferences. All right. Yeah. On the other hand, if we take ordinal data, okay, so here you see the keyword is the nom, okay, so nominal, nom. Now here the keyword is ordinal, so ordinal, ord, okay, so this is the opposite. Ordinal data is qualitative data, which constitutes labels also, it constitutes labels, but with recourse to order or hierarchy. Okay, with recourse to order or hierarchy. And I'll give you an example so you understand. Let's take, for example, now that you've gone to the menu, right? You've gone to the restaurant, they've given you, this menu, you've taken your meal, you are done, and then all of a sudden, a lady or a gentleman walks up to you and they say, thank you for patronizing our services. We want you to rate us. Okay, and then maybe they give you a customer satisfaction form. Okay, so on the customer satisfaction form, they have the following. So let's call this a ratings data. All right, so let's call this a ratings data, and then they have, let's say, average, excellent, average, excellent, what else? Poor. Sorry. Poor. Good. And then fair. Okay. Now here, without even you being told, you realize that there is, yes, they are qualitative in nature, but there is a sense of hierarchy. No matter how shuffled they are, there's a sense of order. You and I know that excellent is better than good. And then what? Good is better than average. And average is better than fair. And fair is also better than what? Poor, right? So here, because there is a sense of order, there's a sense of order, there's a sense of hierarchy, or there's a sense of relative importance. So we call this ordinal data, ord for order, okay, just to help you remember. And nominal is just nom, it's just the names. There's no sense of importance, right? I believe it makes sense.
Yes, sir.
Okay, let's just take one example. So another one is, for example, let's even take academic qualifications. Academic qualifications. All right, academic qualifications. I mean, there are lots. Let's say if I create a data set containing, let's say, a bachelor's degree, so a BTech, a BSc, a BA, a BB. Okay, these are all types of bachelor's degrees. A BEng. Okay, so we have BEngs also. So, but let me constitute them and just make bachelor's. Okay, so if I put everything in there, in general, there are so many academic qualifications, but we know that in general, a paper is a bit lower than a certificate. And then also a certificate is lower than a diploma. And a diploma is lower than a higher national diploma. And a higher national diploma is lower than what's it called, a bachelor's degree. Okay. And then a bachelor's degree is also lower than a master's degree. And a master's degree is also, you know, PhD is higher than a master's degree. Okay. So if I write all these things in here, master's, bachelor's, all these degrees, though they are words, though they are qualitative, but they are inherently connoting a sense of relative importance or order or relative hierarchy. All right. Yeah. That's also another example. And another example I can also give is, you're doing are you doing a course in organizational management or something? Are you doing something like that?
Yes, sir. Yes, sir.
Okay. So do you know about an organogram? Have you heard of
No, sir.
have you heard of organogram?
We've not started.
Have you seen this word before?
No, sir.
Okay. So maybe you'll come across it in due course of your studies. An
Okay.
organogram is simply a hierarchical structure of an organization. So normally it looks something like this. Let me erase the screen. All right. So an organogram looks something like this. Okay. Normally in organizations, you have what the chief executive officer, maybe coming at the top. So let's say CEO, followed by, let's say, the managing director. Then these are directors. Okay. Then maybe you have line managers, the LMs, line managers. Then you have maybe staff. I mean, this is an overly simplistic version. Normally, a typical organizational structure would go all the way, maybe about 8 or 9 steps. Okay, so maybe even so instead of staff, let's call this supervisors. Okay, then I can break this down further. Maybe every supervisor is supervising maybe some team lead. Okay, TL. And the team leads have what staff. Right? So it goes on and on and on and on. This is an organizational structure. We call it an organogram. Okay. So, for example, if I create a data set, all right, and I call it org structure or my organogram, and then I put in CEO, MD, director, supervisor, though these are words, they are qualitative, but they have a sense of hierarchical attributes. And so therefore they would be ordinal data. Okay, so that's just about it on the classifications for data and variables. Now recall that we said the first point in the statistical pipeline is what? Data collection. All right, data collection. And we said that data collection is the process of obtaining the data from its origin or source, its origins or sources. All right. So where is that origin or where is that source? Where will we go and collect that data from? All right. We call that place a population. Okay, the population. So I think everybody knows what a population is, but normally when I ask you, you tell me that the population is what the total number of people living in a country. Well, that's correct. However, that's a limited definition. In the context of quantitative methods, when we say a population, we're not just talking about human beings, all right? Not just human beings. We're talking about human beings and non-humans, all right? So in general, a population is the totality, okay, or the collection of units or elements within a domain, okay, typically over a period of time. Okay, it's the collection or the totality of units or elements within a domain over a given period of time. So you realize that in this particular statement, I did not say anything about country or people, but a country or people can still fit in there. All right, because the units or elements that I made mention of are if it's a country, they will be the individuals, right? And then the domain that I made mention of would be a country, if that's what we're referring to. But it could also mean everything else. All right. So we can talk about the population of a country. We can talk about the population of a university. We can talk about the population of cars in the ATU parking lot. We can talk about the population of bees in a hive. We can talk about the population of trees in a forest. We can talk about the population of what else? Population of buildings in a city. Okay. Hello. Yeah. We can talk about populations of buildings in a city. Okay. We can talk about the population of chairs in a class. We can talk about the population of, tables in a particular building, and so on and so forth. Okay, so these are all things that we can attribute to population. So these are some examples that I've given here. Now, a population can either be finite or infinite. When you have a finite population, it means that it's limited in the number of units. Okay, it's countable. Okay, for example, like countries or university populations or even class populations, it's possible to count. So these are finite populations. Infinite populations are limitless in number. Okay, like we say, the infinitude of the wisdom of God. It means that you cannot place a boundary on the majesty of the Almighty. Okay, his wisdom and is infinite, beyond the expanse of the universe. So anything that's infinite is boundless or limitless. So in the same way, when we say we have an infinite population, there's a population which is composed of a limitless number of elementary units. Okay, so for example, sea, fishes in the sea, it's not possible to count, at least not now with the current technology available. Grains of sand, okay, grains of sand in a particular, from a shore, other particulates matter. So these are the different types of populations. But oftentimes in this course, in fact, in this course, we'll be dealing predominantly with finite populations. Okay. Now, the final thing I would say, then I would draw down the curtains, is this. You see, if we're collecting data, okay, ideally we should go to the population, but think about it. Let's say that in ATU there are about 20,000 students. You're going there to collect data, even if it takes 1 Ghana cedi to print a questionnaire for each participant. That means you need 20,000 Ghana cedis just for data collection, right? Are you following? You need 20,000 cedis just for data collection. Which will be prudent? If you're spending 20,000 on data collection, how much would you actually spend on establishing the business for which you're collecting the data? Okay, so because of this, we have to resort to something called a sample. A sample is a sub-selection, a representative sub-selection from a population. Okay, now we select samples in such a way that it gives us a reduced number, but we can use that reduced number to still draw meaningful inferences about the population at hand. In other words, instead of going to engage with 20,000 people and waste money and also waste time, statistically, it is possible for us to use a smaller number of people to save time, to save money, but also derive credible insights. So we call that a sample. And the process of deriving this sub-selection is what we call sampling. All right. So in our next meeting, we'll be studying sampling techniques. Okay, sampling methodologies. Exactly how do we do the sampling? Okay, so we'll look at probabilistic sampling and then non-probabilistic sampling, and then we'll look at the different types, okay, of probabilistic sampling and then non-probabilistic sampling, and then we move on and on. So if there are no questions, thank you very much. I'll meet you next week. Okay, as the Lord wills. Have a pleasant day.
Have a nice day.
Okay,
Bye.
Have a nice day.